Hello, everybody. Welcome to today's live webinar. Thank you for joining us today. I hope you can hear me loud and clear. I'm Michela Fassi, Communication Manager at Milestone, and I'll be your moderator for today's webinar. This webinar today is dedicated to the frequently asked questions on tissue processing. How did we structure this webinar? We have collected the most frequently asked questions that our customers and prospects usually address us, and we have collected them in order to discuss them with you and try to solve the most common issues in tissue processing. Now, before giving the floor to the speaker today, I would like to grab your attention for a few seconds. Here you can see the basic functions of the Zoom platform through which we are broadcasting. Your microphone will be muted for the entire webinar, but you can, of course, communicate with me in case of any technical problem using the chat. And also you can see the Q&A icon. We suggest to write as many questions as you want, and we will try to answer them at the end of this webinar. Now let's take a look at today's speaker. The speaker today is Irene. She's quite new in the Milestone family, but you will see by yourself today, she's very skilled already in tissue processing. So I'm gonna give her the floor. I'm gonna switch my camera and microphone, and Irene, you have the floor.
Hello, everyone. I am Irene, application specialist here in Milestone. And today I will have the pleasure to talk with you about the frequently asked questions on tissue processing. I have collected the most common questions that our application team receive from our customers and grouped them in 4 main topics to talk about: tissues, laboratory workflow, fixation, and reagents. We will see the common problems and also the possible solution to deal with them. Starting from the core of tissue processing, so the tissue, a frequent request is how is it possible to deal with different kinds of samples? We will see it in 3 different aspects: tissue with different thickness, fatty tissue, and delicate tissues, supported also by photos of real problems that we received. As we know, the tissue types that we encounter during tissue processing are really a lot, with very different thickness, from the small biopsy to the big fatty sample. But what is often done is to consider them almost all equal, and therefore treat them all in the same way. And this is something that often leads to problems in the final results. Well noted are the problems when the sample is under-processed, so the tissue morphology is not preserved. The section may appear cloudy with no chromatin definition in the nuclei, and also the central area of the tissue is difficult to cut, and the block surface is not correctly flat. This is less known, but artifacts are present also in tissues that are over-processed. Here, for example, in this image, we have a biopsy that shows the effects of over-dehydration, where the sample becomes very brittle, dry, and we can see microchatters at the edge of the tissue. It's now evident that to improve the quality of the outcome is important to use an appropriate schedule for the tissue type. So to do this, we suggest to divide the samples by thickness to have the possibility to process them in the correct time. So, for example, A biopsy requires few hours, while a big sample may require 12 hours. So what is possible to do in our processor is to have these protocols dedicated to a specific thickness ready in the unit, and also to easily create personalized protocols for a particular kind of tissue that requires different times. So unlike processing all the sample in the same run, this approach allows to have for sure quality results, avoiding all the problems that we saw, so with over and under processed sample. And also the other advantage is that in this way we can also improve the efficiency of the work, because it's possible to process small samples that need less time during the day. Now, let's look at another type of samples. So we saw this sample with a different thickness, small biopsy or big sample. Now let's look at fatty tissue. This tissue is a kind of sample that usually needs its own dedicated protocols, because this soft tissue is more difficult to be penetrated by reagent. It naturally has an higher lipid content, and I'm sure that you know that dealing with this kind of sample is can be very challenging. So these the lipids present in this kind of specimen act as an optical barrier to light. So they must be properly removed to have an optimal analysis at the microscope. But how these affect the tissue processing? If a fatty sample is not correctly treated, problems are present during the cutting of the block for sure. Section may present holes, and also the tissue tends to separate from paraffin and expand in the water bath, like we can see in this image. And also very important from the microscopic point of view, we can see the adipose tissue as a dense adipocytes network. So this network we can see here is often broken during the processing because of its fragile nature. So if this happens, glands, lymph nodes, connective tissue, and other important areas for the examination can be lost, risking the correctness of the analysis. This management of the fatty tissue has also consequences on the organization of the lab. Why? Because longer time is needed to correctly process or even reprocess these samples, and this leads to delays in the whole process after this step. And another problem is that since this tissue needs longer protocols, it's often necessary to also divide the processor and have one dedicated to fatty tissue that only performs long protocols. So this slows down the entire laboratory work. What we can do is try to better integrate the processing of this tissue into the lab routine. To do this with Milestone units, we have the possibility to process with fast protocols. So fatty samples can be processed during the night and even during the day. So we can have high quality results, but in less time, and in time useful for the work of the lab, so in good time. And most importantly, with the same processor used for small samples, so we don't have to divide the processor. This guarantees for sure a better management of this tissue without delays on the laboratory operations. So we have seen a sample with a different thickness, fatty tissue, and it's now turn of another type of tissue that is delicate tissues. So samples that requires particular attention. These can be for sure biopsies that are small, thin, but also soft tissues like lung, and also tissues that requires a specific orientation. As you know, with this specimen, the embedding step is a crucial one, because if specimens are handled forcefully to make them lie flat in the mold, they can be also easily broken like the example in this image. Another problem is that samples can also show signs of local deformation due to a rough handling with the forceps. So we can see here the hole left by a forceps. Another tissue that requires particular attention is a tissue that also needs a specific orientation, because if the orientation is not correct, the problem is that there is a loss of tissue as re-embedding is required, and also an extensive trimming of the block to obtain a full face section. How we can try to solve these three problems that we saw with the delicate tissues? A tool that can help in this case is Synergy, the Milestone auto-embedding system. Through the auto-embedding, it's possible to handle this delicate specimen only once, and this reduces the risk to damage them, as the orientation procedure is performed prior to the processing step when the tissue is more flexible, and that I handle this specimen only once. So this helps in better managing the specimen, and also another advantage is that avoids the loss of the small samples. So we have seen the most frequent problems related to the tissue type. And now I would like to touch the second topic, that is laboratory workflow. And the questions that usually are addressed to us regards this laboratory workflow are the optimization of the work. And we will see also together the problem of the shortage of isotex. So we will see workflow optimization and shortage of technicians. According to a recent survey with lab managers, the laboratory workflow requires optimization. If the workflow is not well organized, it has a direct impact on how many samples a lab is able to process, how fast, and also with how much pressure for the worker, for the histotech. So the question is how we connect to try to optimize the laboratory workflow. This sentence is taken from an article published on Annals of Diagnostic Pathology, and it tells us how to increase the productivity of the lab. I will use this article to see together the possible solution for this problem. Starting from the first sentence, more cassettes processed during a specific time. I'm sure that you are experiencing in your lab that the fact that the number of cassettes that has to be processed is constantly growing, and it's going to be every day bigger. So being able to process more cassettes is often a key point for a tissue processor. A solution for this in our tissue processor is to have two cavities that allows two processes to be run at the same time. So in this way, we can manage up to 600 cassettes at the same time. And the other very important point is the possibility to apply a lean workflow. But what do I mean for a lean workflow? It means several short runs during the day with thin samples and biopsy. and the longer process for thick and fatty tissues during the night. So this kind of organization can increase the overall productivity and also gives the possibility to process small samples with the appropriate times, as we previously saw. So in this graphic, we can see the traditional workflow on the left with the overnight process, and then the rest of the day, the unit is not used. In our processor, we can achieve a lean workflow. So you can see on the right that in this time, so in the daytime, the unit can be used for short runs. The unit can work. This has also a very positive and important impact on the workload distribution, because there is not a high work volume in the morning when the process with all the sample finishes, but it is better distributed during the day. Why this? Because I can start to process the samples that I have ready in small batches during the daytime. And so this reduces the stress and the pressure for the technician because the work is better distributed. Going on with our sentence of the article, the second one is less time needed to process a cassette. In this case, what I need is a faster process with, again, positive consequences on the number of cassettes that a lab is able to do. And this fast process has to be supported by the appropriate technology. Our hybrid heating system is studied to enhance the exchange within tissue and reagent, and also to speed up this operation, always maintaining, very important, the quality of the final results. And this is what allows us to do these fast runs, fast processes. Going on, the last sentence is more operations optimized or automated. But why is there this need to improve the way these operations mentioned are done? So in this case, with the device. Because again, according to the previous survey with lab managers, another reason for slowing down is the time required for instrument maintenance and downtime. So these kind of operations are, for example, the cleaning of the main cavity from wax, the reagent exchange, and also wax exchange. Starting from the first one, cavity cleaning. Cavity cleaning is for sure a time-consuming procedure. And again, having a double cavity in our processor is a solution because the movement of the wax is not necessary. We have one cavity dedicated to the reagents, alcoholic reagents, and another cavity for the wax. So it's not always necessary to perform the end of the run cleaning. And also there are no wax residues in circuits. Talking about automation, as we saw in the article, between these two cavities in Magnus, the movement of the rack is fully automated. Another big procedure that the processor requires is the reagent exchange. I'm sure that many of you knows that this is a difficult and demanding task. Why? Because tanks have to be manually filled with the risk of spillage of dangerous reagent. You have to move heavy tanks. So the possibility to use commercial tanks instead, like in our tissue processor, drastically reduces the time needed for this operation, and in a few minutes the tank is replaced. It's enough to remove it and insert the new tank. So very fast and easy. And moreover, another big advantage is that this procedure can be performed also during a process. So I don't have to wait that the unit is without a process, because I can do this operation also during a run. So this also saves time. Also for walks, we tried to make things easier. And in Magnus, a walks reservoir is present, so that walks exchange can be done automatically. And after this operation, I don't have to wait the melting time for walks, because I have this reservoir with already melted walks, so I can immediately start a process. All these features gives us the possibility to reduce units downtime and therefore improve the workflow of the laboratory. Directly connected to how the work is managed, the second question in the topic laboratory workflow is how to address the shortage of technicians. This is a problem that, according to a recent report from the National Society of Histotechnology, has reached a critical point. And among the possible solutions displayed in this article, for what concerns us, we can try to act on the second one: support current professionals. What we can do is make the use of the processor easier, more immediate, and with an easy interface, an intuitive use of the unit, and very important, to have a unit that is adaptable to the needs of the lab. So this makes also the learning part less stressful and less difficult. As we previously saw in the article, also through the optimization and automatization of a frequent operation, we can improve the laboratory workflow and improve the workplace. Like these operations are the tank exchange, and again, the possibility to use a lean workflow for a better distribution of the workload. Again, the use of the auto-embedding system, so I don't require the passage of the auto-embedding. And all these measures are little steps that help towards a lighter and less stressful work to support the current professionals. So after tissues and the laboratory workflow, is now time for the third topic, so fixation. Questions that we usually receive from our customer regarding fixation are about the impact that this step has. Why? Because as the first phase, it affects all the process. So several artifacts seen in the slides can be ascribed to this step. So let's talk about fixation. Fixation is essential to preserve the tissue, block the autolysis and the breakdown of cell structures. And the fixation step is one of the most crucial, but also less controlled of all the steps. And it really affects the quality of the final results. If fixation is too weak, the tissue will not resist to the treatments in the later cleaning step, and most of the problems seen in the slides during the analysis can be caused by this incomplete step. So I would like to share with you few photos of the most frequent artifacts, so we can see together what are these problems. The first one is incomplete fixation. So if the fixation step is not well completely performed, as we can see here, the tissue morphology is not well maintained, and the parts of the tissue are completely absent. and cells nuclei are faded. The second problem is delayed fixation. Why? Because the chromatin is not preserved with a delayed fixation. There may be cell shrinkage and also disruption again of the cytoplasm and the overall cell morphology. And the third problem is the zone of fixation. This problem is when formalin acts only on the outside and the time is not sufficient to reach the core of the sample. So the inner part is fixed with the alcoholic solution during the dehydration step, while the outer part with the formalin. So in this image, we can see the difference between the external part and the internal part. From these three examples, we can really see how important this step is for a correct and proper analysis of the samples. The problem is that this important step usually is not controlled, and that the fast turnaround times required in today's laboratories can lead to incompletely fixed specimens. So what we do in our tissue processor, trying to improve this step, is to have a fast fixation that ensures the proper finalization of the step in good time. And the other advantage is that this phase is controlled, and it's also possible to insert fixation limits for those laboratories that follow specific guidelines as the CAP ones. So we now move to our last topic in program. After fixation, we can talk about reagents, and in particular, the question that we usually receive is if it's possible to use a reliable alternative to xylene. Why this? Because xylene is commonly used as a cleaning reagent, but this substance is toxic, and a long-term exposure to xylene affects the central nervous system and may lead to memory loss, coma, and it's also expensive to dispose as a toxic reagent. The ideal solution, of course, would be to use an alternative reagent that has to be safe, but with the same results. What we suggest to use as a reliable alternative is isopropanol. It has a lower toxicity and therefore is safer for the technician. This is the important point, that this is safe. And it has another big advantage. It creates reversible bonds with wax. So unlike xylene that contaminates wax in an irreversible way, wax can be cleaned from isopropanol. So in our units, we can clean the wax, and this cleaning ideally prolongs the reagent life, and so wax has to be changed only every 30 days. So this is a very big advantage. We have in our unit the technology to optimize the use of this alternative reagent, isopropanol, with dedicated xylene-free protocols, and most importantly, without affecting the quality of the results. So we have a good quality with isopropanol, and in our processor is, however, possible to use also other reagents. These, of course, to meet the needs of all the laboratories, and again, to have a unit that fits each laboratory routine. To sum up, we have seen how it's possible to deal with different tissue types, starting from the possibility to use dedicated protocols for small and big samples, then how to better manage fatty samples, and also the synergy, the auto-embedding system that helps with the delicate tissues. Then the second topic, laboratory workflow, how we can work with our processor to optimize it, so through the use of a lean workflow, and also how to make the work easier to meet the problem of the shortage of technician with an easy to use processor and easy operation. Then the fixation and the impact that an incomplete and uncontrolled step has on the final results, and to conclude, the advantages to use isopropanol as a sign-in alternative. We saw our approach, Milestone approach, and how we can face these challenges with our tissue processor. We now have Magnus, the fully automated tissue processor, and the Logos family, Logos and Logos Evo, and also COS, the multifunctional tissue processor. So these topics are only a few, together the most frequent questions that we receive. But my team and I are always available to answer to your questions, and of course to help with additional information and with online demonstration. So thank you very much for your attention. I hope that my presentation has been clear and useful for you, and I'm now available for all your questions. Thank you.
Thank you, Irene, for your nice presentation. Now it's time for questions. So I'm gonna start reading you some questions that already arrived in the chat. But of course, to all the attendees, if you have a question, now is the time to type them in the Q&A box. So Irene, the first question for you is this one. Can you better explain why there is no need for a cleaning cycle?
Yes, of course. So in our processor, there is no need for cleaning cycles, because both in Magnus and in Logos Evo, we have two cavities. So I can also zoom a little bit so we can see better the cavities. Okay, so in Magnus and also in Logos, I have two different cavities. The first one is for all the reagents, so for the fixation, the hydration, and the clearing phases, while the wax impregnation step is performed in the second cavity. So I have a dedicated cavity for the wax impregnation step with inside already melted wax. So it's not necessary to move the wax because I have a cavity with the wax already melted for the last step. So it's not the wax that is moved, but it's the rack that is moved from the first to the second cavity. In Magnus, this movement is done automatically, while in Logos, the same thing in the dual run mode is done by the technician from the first to the second cavity with wax.
Okay, let's continue with another one. Okay, we have an attendee who says, you said that the samples are divided by thickness. My laboratory is small and we process all the samples together. With your processor, is it possible to do this or only divided?
Thank you for this question. So the problem with processing the samples all together is that it's not ideal for the quality of the final results. So in your case, if you have a few samples, a possible solution can be to divide them at least in two batches, in two parts. So one with small samples with biopsies, and the other one with all the other samples, fatty samples, big samples, and so on. So at least in 2 parts. If this is not possible for the organization of the lab to answer to your question, yes, with our unit is anyway possible to process the sample in a conventional way. So just one run with all the sample with an optimal result.
Okay, now let's move to a question regarding isopropanol. The question is, can I use isopropanol as an alternative of xylene in any processor? And how is the embedding with isopropanol?
Okay, so isopropanol can be for sure used as an alternative to xylene, but the advantage to use it in our processor is that our unit is with the hybrid heating system is designed and studied to properly work and have the most benefits from the use of isopropanol. So to use isopropanol as a xylene substitute, you have also to have ready the protocols and the appropriate technology to use it as in our processor. And the use of isopropanol does not affect the embedding step. So the embedding part after the tissue processing is not affected by the use of an alternative reagent as isopropanol. The embedding part is still the same, and as I mentioned, synergy during my presentation, isopropanol is also compatible with an auto embedding system as synergy.
Okay. I have another question here. How many runs is it possible to perform during the day?
Thank you. This is something that really depends on the routine of the specific laboratory. So to do an example, if we have a laboratory that performs a lot of biopsies from a shift, let's say to 8 a.m. from 1 p.m. So in 5 hours, we can do up to 7 runs. Why this? Why we can apply this lean workflow that we were talking about? Because once the first batch, the first part of the cassettes has finished the first phases, so fixation, dehydration, and clearing, and they move to the second cavity to do the wax impregnation step. In the first cavity, I can start with a new run. So the cavity is free. I can start with a new run, and this is why I can do so many runs during the day and save time. Of course, this lean workflow it adapts to the routine of the lab. So it's not something that is equal for everyone. So for example, the big advantage is that usually a lab receives samples not all in the same moment, but during the morning. In a conventional, with a conventional processor, I don't have time to process this sample because I have the long protocol and then the cleaning cycle. The advantage with the lean workflow is that I can start during the day to process the sample that I receive. So this is the main difference.
Okay, thank you. Another question just arrived again about isopropanol. Do you use isopropanol after ethanol alcohol? That means all reagents will be alcohol for dehydration and clearing.
Yes, isopropanol is used after ethanol. So all the reagents correctly are alcohol-based to perform the processing. So the dehydration phase is performed with pure ethanol, while the clearing phase is performed with pure isopropanol, and then the wax impregnation step.
Thanks again, Irene. I think this question is also related. At what concentration of isopropanol, so which concentration of isopropanol do you use for xylene, and what kind of wax do you use?
Thank you for the question. The isopropanol that we use is pure isopropanol, so 100. And usually we suggest to use isopropanol until it reaches the 98% of purity. And regarding this, a big advantage that Magnus has is that we have inside the unit an alcohol sensor that tells us in a scientific way the purity of the alcohol that we are using, and so also when it's time to exchange the alcohol in a more precise way. So isopropanol 100.
Thanks again. I think that time is running out, so we have time for one final question. Is it possible to also improve the management of super mega cassettes? In my laboratory, it is the longest process.
Yes, it is possible. Actually, this is something that a lot of our customers have improved thanks to our processor. I was recently in a lab that performed this operation in a few days, but regarding the tissue processing part for the super mega cassette, it takes 2 days, one for the fixation part, more or less, and one another entire day, more or less, for the other steps. With Magnus, we obtained the same results, but overnight. So not today, with the unit busy for 2 days, but just 1 day. So yes, it's possible also to better manage super mega cassettes.
Perfect. Thank you again, Irene, for your explanation. I'm gonna share one final slide with you. Here you can see our contacts. So in case you need further explanation from Irene or the application team, in case you need a customized virtual demo from us, please do not hesitate to contact us. And here you can see our email. As for the webinar series, we now take a break with the webinars. We will have more webinars and events in the second part of this year, and for the moment you can rewatch the webinar, the Milestone webinar that we recently recorded. So here is our website link to find and rewatch all our past events. You can also stay up to date with our news by following us on our LinkedIn and Facebook pages. I know that we have a few questions that we have actually didn't answer to. We will answer them via email in the next few days. You also tomorrow you will receive the recording of this webinar. So thank you everybody for watching and participating, and we hope to see you all next time. Goodbye.
Thank you.